Welcome to Precipitation Part 3, everything you want to know but were afraid to ask. This is for ESCI 211. So let's get started. Alright, so after this online lecture, you should be able to review the cloud's liquid water content, know the definition for rain, how we identify the intensity of rain, drizzle, and so forth, the definition for snow, the shapes, the intensity, and the types of snow, know the definition for sleet, know the definition for freezing rain, understand the lapse rates, the environmental lapse rate for all precipitation created in the atmosphere, and the definition for hail, and the instruments used to measure precipitation. So let's move on. Okay, so we have two types of clouds that we've talked about before. We have the low liquid water clouds, or the nimbostratus, and the high liquid water clouds, and the cumulonimbus. So everything starts as ice crystals, except in the low liquid water clouds, these ice crystals are diffuse, and then they collide and create larger ice crystals. They use aggregation to grow, and then we get our snowflakes. Now, depending on the environmental lapse rate in the bottom part of the cloud, if it's warm enough, the snowflakes will melt and we'll get rain. If it's below freezing, the snowflakes will stay snow and we'll get snow. Now, if we come over to the high liquid water clouds, or the cumulonimbus clouds, what happens is you get riming in the upper atmosphere, the upper heights of the clouds, and it creates the rimed crystals, and this produces the grapple of a type of snow. And then again, if the temperature profile is warmer than 0 degrees Celsius, the grapple will melt and we'll get rain. Now, if it's not warmer, then if it's below 0 degrees Celsius, we can get hail that comes out of the bottom of these clouds. So that's our review of our liquid water content for the clouds. So let's talk precipitation. In this case, rain or liquid water. So how we define what drizzle is: the diameter of the raindrops are less than or equal to 1/2 millimeter. You can also have virga, which is what's called evaporating streaks of precipitation. So if you look at the picture here, let me see. If you come over here and look at the picture, you can see these streaks right here. That is rain falling from the cloud, but it evaporates before it hits the bottom of the hits the surface of the earth. So we don't get any precipitation on the ground. So let's talk about intensity of raindrops. So one type is called a shower. So you get a sudden release of water droplets. Now, if you get a heavy shower, that's referred to as a cloudburst. So here's the types of intensity of rainfall, and it's all based on the amount of rain we get per hour. So you get a heavy rainfall is greater than 0.3 of an inch of rain per hour. And then, okay, let's talk about some snow. Most precipitation starts as snow. The shapes of the snowflakes depends on the temperature at which they are formed, and we'll talk about this a little bit more. And if you look at table 7-3 in the book, it gives you a list of what environmental temperatures you have to get particular snowflakes. So if you want to get the nice snowflake patterns, that are these dendrite patterns in snowflakes, you have to have temperatures in this range. So what do these snowflakes look like? Well, they look like this. Here's the classic dendrite snowflake right here. Right? It's got that classic snowflake. Here's some other forms of snowflakes. So here's what we call plates, columns, dendrites, and needles. So you can have lots of different types of snow falling, and it all depends on what temperature these snowflakes were formed in. So you can detect if rain is, if the precipitation starts out as snow, using the ability of snow to scatter more light than rain. So if you basically look at the bottom of the cloud and you got this dark region and it turns lighter below that, then you know the darker region is snow and the lighter region is rain, and you can detect the melt line between the snow and rain interface. All right, so how do we determine the intensity of snow? That's based on the visibility you have. So to be in a heavy snowstorm, you got to have visibility of less than 1/4 of a mile. You can also, if we get blowing winds, we can get blizzards. And you can also get snow grains, which is basically snow's versions of drizzle. And you can also get snow pellets. Basically, they're just like snow grains, but they contain more air pockets in its structure, so they tend to be a little bit bigger. All right, so how do we get snow? It depends on the temperature profile. If you look at this temperature profile, this is all below 0 degrees Celsius. So if that happens, if the ice starts in the top of the cloud, it doesn't have time to melt. The ice particle can grow, and it grows into a grapple, and then it falls out as a snow pellet. So in order to get snow, the temperature in the atmosphere has to always be less than 0 degrees Celsius. Okay, if that's true all the way to the ground, we'll probably see snow on the ground. Okay, let's talk about sleet. Basically, sleet is tiny ice pellets that hit the ground. Now, to create sleet, you get this region in the atmosphere that is at a temperature above 0 degrees Celsius. So this region right here, as you go up in the atmosphere, we have what is called a temperature inversion here. So the temperature goes up for a while and then it goes down, and this gives us this above freezing layer of air. And so the snowflake will come out of the cloud, enter this warmer air, and start to melt into a raindrop. But then below this warmer air, you've got what they refer to as a deep freezing layer of air, and that's deep enough so that the raindrop completely freezes into ice and we get sleet. All right, let's talk about well, we're talking more about sleet. I've basically covered all this. Causes the ice crystal to melt, and then it refreezes in the warmer air, the colder air below the warm layer. All right, let's talk about freezing rain. So again, the ice crystal falls through a much thicker layer of warm air, and so the snow will melt and we get rain, but then there's a shallower layer of freezing air compared to the sleet. So the layer of freezing air above the ground is much thinner, and what happens is that this raindrop now will supercool, and when it hits the ground it will freeze. When it contacts the ground, it will freeze. All right, let's talk about the temperature profiles in the atmosphere to create this precipitation. So to get snow, our temperature profile has to always be lower than 0 degrees Celsius. To get sleet, the rain has to fall through a layer of warmer air that is warmer than 0 degrees Celsius. Okay, so this air in here is warmer than 0 degrees Celsius. And then it falls through a deep layer of colder freezing air here, and so that the sleet will freeze all the way and it hits us an ice pellet. So, but the difference between that and freezing rain is, if you see here, is our freezing layer here is much smaller and our warmer layer is much larger. So there's not enough time for the raindrop to completely freeze again, but it super cools, and when it hits the ground, it freezes, or hits an object on the ground, it freezes. And then you got rain, and you'll see it's got it gets above the freeze line here and never hits it again until it gets to even when it gets to the ground. So we get rain all the way down. So these are the environmental lapse rates for all the types of precipitation we see in the atmosphere. All right, let's talk about hail. Hails are pieces of ice that can be transparent or opaque. They range from the size of peas to the size of softballs. And the larger ones are usually aggregations of smaller ones stuck together. All right, so they're formed through accretion inside clouds, mostly cumulonimbus clouds. The type of ice used to form the hailstones depends on the water vapor content in the cloud. And what usually happens is that you get these strong updrafts. It holds the hailstones in the air longer, and sometimes you can get them to be larger and larger as they're held up into the updraft. And then they get too heavy, they'll fall out, and we'll get hail this way. Sometimes they can get such a strong updraft that they're shot out the back and land in a place where there's no storm going on. All right, so how do we measure precipitation? Well, we use instruments like a standard raise gauge, which is basically just a cylinder and a funnel, a rain gauge called a tipping bucket, or a weigh type of rain gauge, and then we can measure snow measurements by just going out with a big stick and measuring how deep the snow is. Another way is they'll scoop up a certain volume of snow, melt it down to figure out how much water is contained in the snow. The book has much better details on these precipitation instruments, measuring instruments, so I'd recommend you look there. All right, so another way they do it is Doppler radar. This has some advantages. You can see it for a farther distance. It also has some disadvantages. You don't see anything close to the ground. It only gets about 1,000 feet into the air, and then if it gets closer to the ground, the radar can't see it. The disadvantage for the standard rain gauge is the other rain gauge. You have one rain gauge and one localized location, and it could not be raining there, so you wouldn't count that precipitation unless it gets into the bucket. So in order to get more accurate precipitation readings, you got to have multiple rain gauges across a larger area. All right, so here are two ways you can contribute to citizen science measuring precipitation. You've got the Cooperative Observer Program and the Precipitation Identification Near the Ground Project, or PING. PING is an app. If you search for PING on the iTunes or the Apple Store or on the Google Play, you should come up with an app that you can download, and it's free. And it steps you through the process of identifying what type of precipitation you're seeing. The Cooperative Observer Program, you can join that for free, but you need to buy their rain gauge, which is about $35, and then on a regular basis go out and measure the precipitation in your rain gauge and report that information to a particular website. These websites will get you in contact with more information about these programs if you're interested. All right, so let's review our learning objectives for today. So you should have a better understanding of clouds' liquid water content, a better understanding of definition of rain, what's the temperature profile of the atmosphere to have rain, how do we determine intensity of rain, how do we determine if rain is drizzle, definition for snow, what is the temperature profile in the atmosphere to get snow, what types of shapes do we have in snow, what causes the shapes to be different, what types of intensity do we have, the definition for sleet, what is sleet, and also the temperature profile that creates sleet. How is this profile different than from freezing rain, or snow? You should know what the definition of freezing rain is. the temperature profile that produces freezing rain, how is it different from sleet, rain, and snow, and then the definition for hail, how is hail produced in cumulonimbus clouds, and then how we measure precipitation. So either it's a rain gauge, or that is electronic that can be the measurement for ourselves, or it could be using a radar or Doppler radar. So that's all I have for part 3. I'll see you in chapter 8.